and welcome to our online class for this week. Last meeting we have discussed about radicals, and today we are going to tackle a new topic, which is relation and function and its domain and range. But before that, let me introduce to you the objectives for today. At the end of the discussion, students will be able to first, define relation, function, domain, and range. Second, differentiate relation from function and domain from range. Third, cite examples from real-life situations. I believe that this topic is familiar to you because you have undergone this during your grade 11. Now let us start. What is a relation? A relation is a set of ordered pairs wherein X is an element of A and Y is an element of B. It relates every element X to have corresponding Y values, and it is a one-to-many correspondence. In other words, a relation is a Cartesian product wherein all the elements from A cross B can form an ordered pair, or it is a set of ordered pairs wherein every X value always have a corresponding Y value. Lahat ng X value ay may partner na Y value. And this one-to-many correspondence will be understood as we further discuss. Order of relations. The order of a relation can be less than, greater than, less than or equal to, greater than or equal to, and not equal. We have an example here. In A cross B equals to the ordered pairs 1 and 2, 2 and 1, 2 and 2, 3 and 4. What are the elements of a relation if R is equals to the set of ordered pairs A and B, if A is less than B? Now we have here R is equals to set of ordered pairs 1 and 2, 3 and 4. As you can see on your screen, this ordered pair here follows the format A is less than B. You see, the A in the first ordered pair is 1, which is less than 2, and the second pair have 3 as its X, which is less than the value of its Y, the 4. Now we have the examples of a relation. Number 1, the set of ordered pairs negative 2 and 1, negative 1 and 2, 0 and 3, 1 and 4. As you can observe, this relation, it shows the definition that every X value has its corresponding Y value. Now we have the second example, a cell phone brand manufacturing different phone models. This example is the real-life example of the one-to-many correspondence. Why? Because let's have Samsung. If we are going to be specific, in this example, we have cell phone brand named Samsung. Samsung is a very popular cell phone brand in our country. Samsung, even though it is only a one name for a cell phone brand, however, it manufactures different phone models or versions every year, right? One model but has different kinds of phones, like they have Samsung Galaxy S5, Samsung Galaxy J2 Prime, Samsung F9 or S9. They have that, so that is one-to-many functions. They have same brand but different versions. Just like in a relation, they have the same X value but different Y value. Now we have a relation. How can a relation be represented? A relation can be represented as words, like the first example that we have. Second, ordered pairs. Third is graph. Fourth, table of values. Fifth, mapping. Sixth, equation and inequality. Now let's proceed to function. What is a function? A function is a special type of relation wherein there is no distinct ordered pairs have the same first element, which is the x. Every input, x, only have one unique output, which is y. It is a one-to-one correspondence and a many-to-one correspondence. In other words, a function is a type of relation. However, it cannot be possible that a function have the same first element. So in function, it is not allowed that the set of ordered pairs have the same x. So hindi pwede na magkakatulad sila ng x value. And every x value or input have one unique output, which is y. One-to-one and many-to-one correspondence will be understood as we continue discussing. We have examples of function. Number 1, R is equals to the set of ordered pairs 1 and 2, 2 and 3, 3 and 5, 4 and 7. As you can see and observe, there is no x value that repeats. No x or input repeated. They are all unique. 1, 2, 3, 4. Now we have number 2, a toothbrush and its owner. It is a real-life example of one-to-one correspondence. Why? 1-to-1. A toothbrush and its owner. A toothbrush can only be used by its owner. It cannot be that a toothbrush can be used by two persons, right? So it is 1-to-1. And function, we can have a keyword for function as loyal because it has only one. It is for only one object and one value. Third, we have this graph representing a function. Now, we have how can we represent a function? A function can be represented as ordered pairs, mapping, table of values, equation, and vertical line test. Well, this vertical line test is very useful for us, especially in determining if a graph is a function or not. So how can we determine through this test if it's a function or not? Say you can see here a parabola graph. We have to draw a vertical line in a graph. And once this vertical line touches the graph once, if it only touches the graph once, it is a function. However, if it touches the graph twice or thrice or more than one, it is not a function. Now let's proceed to domain and range. Okay, domain. It is the set of all x values or the inputs or the x ordinate. Now the range. Can you read the range?
Is the set of all y values, possible outputs, or the y ordinate, also known as the image of
Okay, thank you. In simple words, domain is only the set of all x values in a set of ordered pairs. While on the other hand, range is the set or the list of all y values in a set of ordered pairs. Now let's have examples. Example number 1. R is equals to the set of ordered pairs 1 and 2, 2 and 4, 3 and 6. Now, A. Find the domain. B. Find the range. How about you? Let's have a pre-answer. Have an answer before we're going to proceed to before we're going to reveal the answer. What will be the domain in this ordered set of ordered pairs?
1, 1,
Okay,
2, and
1, 2, 3 is that the domain? Let us find out later. Now we have the range. What would be the range in the set of ordered pairs?
2, 4, and
Okay,
6.
2, 4, 6. You should remember your answer. Now let us find out. Okay, the domain is range is 2, 4, 6. You get it right? That's good. Now why? Why is the domain 1, 2, 3? And why is the range 2, 4, 6? Now let's see. It is the domain, the 1, 2, 3, because it is the x coordinate. Those are the x values in the ordered pairs. While the 2, 4, 6 are the y values or the y coordinate of the set of ordered pairs. Now, this is, as you can see in the screen, this is an image representing the function or the process of how domain and range function in a function, or what are the rule in the function. So domain or the x values are the input, while the function serves as the process, while the output serves as the possible outcomes of the input. So we have here an example, domain 1, 2, 3, 4, and the function process f of x is equals to 2x. So you just have to what? Yes, you just have to substitute the value of domain to the function so that you can get the output or the range. So we have here 2x. We have the first x, 2x, you substitute the 1, so 2 times 1 is equals to 2. So, right? And you can continue that. So, you can see, you can visualize that the domain and range in a function serves as the input and the output. And the function or the equation like f of x or equals to x serves as the process. A reminder, this f of x equals to 2x can be changed. It is not constant. We have a lot of function or equation about function. This is just an example. Now let us see if you can differentiate relation from a function. Now, is this a relation or a function?
Function.
It is a function. Because from the definition from earlier, it is a many to one correspondence. Because the definition also says that the function cannot have the same abscissa. They cannot have the same x element. However, they only have the same y. They only have the same y value here instead of x. Now next we have this. Is this a relation or a function?
Function.
It is either a relation or a function. Why? Because in the definition of a relation, it is a set of ordered pairs wherein every x have a correspondence of, or it has a corresponding y value. But here, as you can see, the number 2 in the domain or the x value 2 doesn't have any value of y. So it is not. It is either a relation or a function. Now let's have this. We have 5 statements. I want you to raise your left hand, and the pinky will start here. 1, 2, 3, 4, 5. I want you to fold your fingers if an item is a function, is a relation. And if it is a function, let it stand still, okay? So we have number 1, a student and his ID. Number 2, a mango tree and its fruits. Number 3, Sebastian and his children. Number 4, Jim and Rick sharing an umbrella. Number 5, Linda and her password. I'll give you 20 seconds. Okay. Oh, you're a very fast learner. Now let's see. Function, relation, function. Did you get it right?
Yes, ma'am.
Okay. And so this is the end of our discussion. Thank you for entering and listening
Thank you,
to
ma'am.
this class. I hope you have learned something. See you on our next class.
Ma'am,
Thank you.